Welcome to Brain Vision.
This question asks us to take a look at identifying acidic cations. So cations in some salts can behave as acids. So the first example that we have is the ammonium cation. And so that we can kind of see has the ability to donate a hydrogen ion under the right circumstances. So chemistry would look something like this. The ammonium cation in solution would react with water to donate a proton to water and form the hydronium cation. So there's our acidic substance, and ammonia, its conjugate base, would be left in solution then. So ammonium cation is indeed acidic. B asks if the sodium cation is acidic, and is not. And group 1 metals in general, like sodium, do not react with water to form any sort of an acidic solution. So answer choice B is not an acid. C is a transition metal. It's cobalt 3 plus is a cation. And this gets a little trickier, but here's the deal. Transition metals like cobalt frequently form complexes with water. So this is a hexa complex that's commonly seen with cobalt 3 plus. When it forms that water complex, it has the ability to react with additional water molecules to donate a proton or allow these water groups to basically divide into or hydrolyze into the hydroxide and a proton. A proton from one of these water groups gets donated to the water that it interacts with to form the hydronium ion. So here's an acidic species, and what's left then is 5 water groups in the complex, and again, the proton got donated to the water to form the hydronium ion. A hydroxy group is left as part of the complex now. And overall, um, again, the ability of the conjugate, not the conjugate, but the transition metal to interact with water allows it to behave in a way that produces an acidic solution. So that's fairly common for transition metals like cobalt or iron or some of the other transition metals. So this is a methyl ammonium, and again, notice the presence of that positive charge and hydrogen with it. Sure looks like it can donate a proton just as ammonium cation did. So, and indeed, we're going to see a similar reaction here. When it comes in contact with water, it can donate a proton to water to form our acidic species, the hydronium cation, and leave behind a methylamine as the conjugate base.